In the beginning, there was nothing. A vast, silent emptiness devoid of light, time, and matter. Then, in a single, incomprehensible instant, the universe was born. An explosion of unimaginable energy, a brilliant flash in the void that set in motion the grand cosmic ballet. From this singular heartbeat of time, everything we know and everything we don't began its journey. Space billowed outwards, and as it expanded, it cooled. The primordial energy began to coalesce, forming the first elementary particles. Gravity, the silent architect of the cosmos, started its work, pulling these particles together. Over millions of years, vast clouds of gas and dust, known as nebulae, began to swirl and collapse under their own weight. Within these stellar nurseries, immense pressures ignited the first stars, setting the dark expanse ablaze with light. Galaxies, majestic islands of stars began to form, each a breathtaking tapestry of light and gravity. Trillions of stars, each a potential sun, flickered into existence across the ever-expanding universe. Swirling cosmic dust, illuminated by newborn stars, painted the void with vibrant, ethereal colors. Our own story, the story of Earth, begins here, in one of these countless star-forming regions, within a galaxy we would one day call the Milky Way. About 4.6 billion years ago, within a swirling cloud of interstellar gas and dust, a new star ignited. It was a violent, youthful star, our Sun. Its birth sent a powerful shockwave through the surrounding protoplanetary disk, a spinning accretion of leftover material. From this cosmic chaos, a new system was born, our solar system. Gravity, the relentless sculptor, began to pull the dust and gas into clumps. These clumps grew, sweeping up more material in their orbits, their gravitational pull increasing with their mass. Countless collisions, some gentle, some cataclysmic, defined this era. Dust became pebbles, pebbles became boulders, and boulders smashed together to form planetesimals, the building blocks of planets. The inner solar system was a violent shooting gallery. Fiery, molten protoplanets spun wildly, their surfaces constantly reshaped by a relentless bombardment of asteroids and comets. It was a time of fire and fury, a cosmic forge where worlds were hammered into existence. Amidst this celestial demolition, Derby, one particular collection of matter, in just the right orbit, was on a path to become something truly special. A world unlike any other we have yet discovered. This world was Earth. It began not as a tranquil blue marble, but as a hellish sphere of molten rock. Born from billions of collisions, its surface was a glowing, red-hot ocean of lava, thousands of degrees hot. For millions of years, the bombardment continued, with meteors and asteroids constantly striking the young planet, adding to its mass and its heat. There was no land, no water, no air, only a glowing fiery orb in the darkness of space. Slowly, over an immense stretch of time, Earth began to cool. The heaviest elements like iron and nickel sank towards the center, forming a dense metallic core. This process generated a powerful magnetic field, a protective shield that would one day guard the planet against the sun's harsh solar winds. As the surface cooled further, a solid crust began to form, though it was constantly broken and reformed by intense volcanic activity. Volcanoes raged across the surface, spewing gases from the planet's interior. This primordial atmosphere was thick with water vapor, carbon dioxide, and nitrogen, but held no oxygen. As the planet continued to cool, this water vapor in the atmosphere began to condense. The first rain began to fall. It wasn't a gentle shower, but a global deluge that lasted for millions of years. A world of fire was turning into a world of water as the first oceans began to fill the vast basins of the young Earth. The young solar system was still a chaotic place. Our planet was not alone. It's believed that another world, a protoplanet roughly the size of Mars, which scientists have named Theia, shared a similar orbit. A cosmic collision was inevitable. In the most significant single event of Earth's history, Theia slammed into our planet in a glancing blow. The impact was beyond comprehension. Both worlds were catastrophically deformed, vaporizing rock and sending a colossal plume of molten debris into orbit around the wounded Earth. The energy released was immense, once again turning our planet's surface into a global ocean of magma. But from this unimaginable destruction came a constant companion. Over thousands of years, gravity went to work on the orbiting ring of debris. The molten fragments began to clump together, their mutual attraction pulling them into a single, spherical body. This new celestial object, born from the very substance of our own planet, was the Moon. Initially, it orbited much closer to Earth, appearing enormous in the sky. Its powerful gravitational pull created immense tides in Earth's magma ocean, and later, its water oceans, shaping the planet's rotation and stabilizing its axial tilt, creating the predictable climate that would prove essential for the future. With a stable orbit and a loyal companion, Earth's surface finally settled. The oceans, now vast and deep, covered most of the planet. They were a chemical-rich soup, energized by lightning strikes from the volatile atmosphere and heat from hydrothermal vents on the ocean floor. In this warm, primordial cradle, something miraculous began to happen. Simple organic molecules, the building blocks of life, started to form. Perhaps delivered by comets or synthesized in the chaotic environment of early Earth, these molecules began to interact, link together, and form more complex structures. Over millions of years of trial and error, chemistry became biology. The first self-replicating molecules emerged, and from them, the first simple cells. Life had begun. These early life forms, simple single-celled organisms, began to transform the planet. Through photosynthesis, they started to release a waste product into the atmosphere: oxygen. This great oxidation event was toxic to much of early life, but it paved the way for more complex organisms that could harness this powerful new gas. The oxygen-rich atmosphere developed the ozone layer, shielding the surface from harmful ultraviolet radiation. Continents formed and drifted, oceans shimmered, and the sky turned blue. From a single point of light to a swirling galaxy. From a disk of dust to a fiery world. From a molten sphere to a water-covered planet. From sterile rock to a living biosphere. 4.5 billion years of cosmic and planetary evolution, a chain of chaotic, violent, and beautiful events, have led to this moment. To the only home we've ever known, a stunning blue jewel, teeming with life, glowing in the sunlight. All of it, leading to us. Thank you for joining us on this journey. If you enjoyed this exploration of our origins, please consider liking this video and subscribing for more stories from our incredible universe.